Next task, we'll try something from chapter 3, question 13, 16 and 17 from tutorial. If you see chapter 3, thirteen, 15 and 17. So 13 and 15 are very similar and can be done in a similar way. 17 is a bit trickier. One will try to solve the 17th one. 17th one is the same as in 6th edition. Question number 15. The Tucker Outfitters plans to market a custom brand of packaged trail mix. The ingredients for the trail mix will include raisins, grains, chocolate, chips, peanuts, and almonds, which cost individually 2.5, 1.5, 2, 3.5, and 3 pounds respectively. And the table shows the quantity of vitamins, minerals, and protein and calories in each of those ingredients. And most likely the constraint is like the packet needs to have at least 40 grams of vitamins, 15 grams of minerals, and 2 grams of proteins, and 60 calories of 600 calories per 2 pound package. This 2 pound package refers to the weight of the packet. Additionally, they want each ingredient to account for at least 5%. That means the raisins should be at least 5% of the weight of the package. So 5% of 2 pound and 50% and no more than 50% of the 2 pound. So let's let's solve this. First formulate the LP and we'll solve it in the Excel. So we'll copy this first and we'll paste it over here. Okay, and copy this and so here is question 17. So let us consider the quantity of quantity of resins equals to P1. For each product it's P1, and for grains equal to P2. For chocolate it's P3, and for peanuts it's equals to P4. For almonds it's equals to P5. So if we consider, let there be P1 amount of raisins, quantity of raisins, P1 pounds, and P2 pounds of grains, and P3 pounds of chocolates, peanuts, and almonds. This 5 is our decision variables, and what would be our objective? Our objective is to minimize cost. Minimize cost, that is 2.5 P1 plus, if we use P1 quantities of raisins, it's going to cost us $2.5 per pound. So cost of using P1 pounds would be 2.5 P1. Similarly, it would be 1.5 P2 and 2 P3 plus 3.5 P4 plus 3 P5. This is our objective, to minimize the cost. And what are the constraints? Constraint is, one is vitamin constraints, one would be mineral constraint, another would be protein, and the third one is calories. So if we use P1 amount of raisins and P2 amount of grains, so amount of vitamins in P1 amount of raisins and P2 amount of grains would be 20 P1 plus 10 P2. So 20 P1 plus 10 P2 plus 10 P3 plus 30 P4 plus 20 P5 is the total amount of vitamins in the content, and this should be at least 40. Okay. Similarly, for minerals it would be 7 P1 plus 4 P2 plus 5 P3 plus 9 P4 plus 3 P5, and should be it is 15 grams, so it should be less than equals to 15. So similarly you can fill for protein and calories. Apart from these four constraints, there is additionally one more constraint, that is each of these P1, P2, P3, P4, P5, they all needs to be no more than 50% of the weight of the package. Weight of the package is 2 pounds, so they need to be less than individually 1 pound and to be greater than 5%, that is 0.05 into 2, that is 0.1. So this is minimum and maximum weight constraint. So let's create the spreadsheet for this. So I have filled the values here. So this is like quantity used and cost. I'll make this as gray to make sure these are the decision variables, and these factors I can copy it from here: 2.5, 1.5, 2, 3.53, 2.5, 1.5, 2, 3.5, 3. Sorry, this is 1.5. Now let this be total cost. Total weight, this total weight is equals to sum of all these weights, and this total weight should be equal to 2. This is a constant, so I'll make it as red. Apart from this, we have we forgot this constant to mention it over here, that P1 plus P2 till P5 should be equal to 2, because the sum of all the weights should be equal to 2 pounds. So this that constant, and objective is the cost, total cost, and total cost is equals to sum product of the cost of each component multiplied with amount of each component used. So this is our objective. Okay. Now minimum amount of vitamins is 40, minerals is 15, and 10 grams of protein and 600 calories. So 10 and 600. Content is equals to sum product of this, comma, this. So to make this constant, I'll use C4, and for this I'll anchor C and G, and extend the formula. Just double check once. Yeah, fine. And then weight, minimum is 0.1, maximum is 1. We can start putting the constraints here. Go to the solver, say I6. We want to minimize it. Decision variables are the weights. Subject to the constraints, these values should be greater than or equals to these values. We need to add this total weight should be equals to this weight, and these all values should be lesser than equals to the maximum weight, and these all values should be greater than equals to the minimum weight. Okay, make it as an LP, solve it. So we find in that 2 pound package we have 0.75 pound of raisins, 0.1 of grains, 0.1 of chocolate, 0.95 peanuts, 0.1 almonds, and the minimum cost of this mixture satisfying the minerals, vitamins, protein and calories constraint is 5.85. Thank you.